Now we've just thrown out a whole lot of ideas that we need to connect together. Let's organize our thoughts and then begin to see if we can prove that these behaviors obtain using what we do know about the electric and magnetic fields. So what we're going to try to show is the following. We're going to show that if we take the time derivative of total energy stored in the field in our given volume, and I'm about to write down how to calculate that energy. In fact, let's write that down right now, where the total energy stored is equal to then the integral over our volume, like so, integral over the volume V of the electric and magnetic energy densities to get the total electromagnetic energy. And those densities we had shown above are epsilon over 2 times the strength of the electric field squared, right? So that's the magnitude of the electric field vector squared. That's the electric energy. The magnetic energy density we saw was very similar. It's 1/2, but mu naught, and mu naught is on the bottom, times then the square of the magnetic field. And that integrated over our volume. If we take the time derivative of this, what we hope to get out then is, of course, minus the power that we can account for that is coming out of our volume. And that power, recall, had two different components. There was the power that's coming out of the electromagnetic field and is being put into charges, which I will call Q. And then there's the possibility that there's some other way energy might escape from our volume that we haven't accounted for yet. So I will just call that P out other. And what we're hoping perhaps is that when we compute the derivative of this quantity, what we're going to get back is just the power out in the various charges, and then that would prove that there is no leakage of energy. There's no other missing energy terms that we haven't yet accounted. For that to work, then, what we have to get back out is minus this PQ out, and we also have a nice formula for that as just the integral again over the entire volume V, but now the integral, as we had shown, was just the current density J dotted with the electric field E dV. And this then is what we hope to show.